The relentless chase begins. Every time the skies darken over the Great Plains, a quiet tension spreads across the wide, endless horizon. The winds shift, the clouds lower. The air grows heavy, almost electric, and something primal stirs inside the people who have devoted their lives to understanding the most violent storms on Earth. Tornado hunters, also known as storm chasers, are the rare individuals who run toward danger rather than away from it. Their mission is not thrill-seeking, it is scientific. Their dedication, their courage, and often their obsession have helped decode the mysteries of tornado formation, behavior, and destructive power. With every chase, they put their lives on the line. At any moment, shifting winds, unexpected debris, unpredictable rotation, or sudden path changes can transform a research mission into a fight for survival. Yet they willingly accept the risk because the data they recover helps meteorologists refine tornado warnings, extend lead times, and ultimately save countless lives. The story of tornado hunters is a story of determination, loss, discovery, and the unending quest to understand nature at its most violent. Their work compresses into the span of minutes, 8 minutes in some cases, the time it takes for a supercell to evolve into a tornado capable of destroying an entire town. For scientists and hunters alike, every second counts, because tornadoes are both incredibly powerful and incredibly mysterious. To understand why these hunters risk everything, you must first understand the terrifying beauty of the storms they follow inside the mind of a supercell. A supercell thunderstorm is the most dangerous and complex storm on Earth. Unlike ordinary thunderstorms, a supercell contains a rotating updraft known as a mesocyclone. This rotation is the key ingredient in tornado formation. Storm chasers study these massive storms from the outside and inside alike, tracking their rotation, wind structure, temperature changes, and how the storm evolves over time. When a supercell begins to organize, the sky transforms. The atmosphere becomes layered with swirling shapes, rolling clouds, and a greenish tint that signals hail and severe instability. For chasers, these visual clues are everything. The structure of the storm tells them where to position their vehicles, where to place instrumentation, and how to anticipate the tornado's path. Inside the mind of the supercell lies intense chaos and symmetry at the same time. Updrafts pull warm air upward at incredible speeds, while downdrafts blast cold air downward. These opposing forces feed each other, maintaining the storm's structure and potential. The stronger and more sustained the rotation becomes, the more likely a tornado will form. Chasers study this moment, the birth of a tornado, because it remains one of the least understood processes in meteorology. Despite decades of research, scientists still cannot answer the most fundamental question with precision. Why does one supercell produce multiple violent tornadoes while another identical storm produces none? Tornado hunters risk their lives to collect the data necessary to solve this mystery, because the answer could transform emergency response forever. The science behind tornado hunting vehicles. To survive the violent winds and flying debris of a tornado, hunters need more than courage. They need machines engineered to withstand extreme conditions. Some of these vehicles have become legendary within the storm chasing world, built with reinforced armor, low ground clearance, bulletproof windows, and hydraulic systems designed to anchor them to the ground. Vehicles like the Tornado Intercept Vehicle, TIV, and Dominator series are mobile research labs. They carry onboard cameras, wind sensors, atmospheric probes, pressure readers, and radar systems. These chasers do not merely observe tornadoes. They attempt to place themselves directly in a tornado's path to gather data that stationary instruments cannot. The design of these vehicles is a delicate balance between mobility and protection. A chase vehicle must be fast enough to outrun storms, durable enough to survive debris, and stable enough to endure extreme crosswinds. A tornado can produce winds exceeding 200 miles per hour, powerful enough to flip cars, strip trees bare, and sweep entire houses away. The data collected from these vehicles has helped scientists better understand wind speeds inside the funnel, surface pressure drops, and the chaotic internal structure of tornadoes. This information feeds into advanced prediction models, improving warning systems and potentially saving lives during future storms. Yet, even with armored vehicles, tornado hunting remains an incredibly risky pursuit because instruments and steel cannot protect chasers from every unpredictable threat. The dangers that cannot be predicted. Tornadoes pose countless dangers that even the most experienced storm chasers cannot always foresee. One of the most perilous factors is debris. When a tornado touches down, it acts like a massive vacuum, pulling up pieces of homes, trees, vehicles, fences, and anything else in its path. These objects become high-speed projectiles capable of piercing metal and shattering reinforced glass. Visibility often becomes a deadly challenge. In rain-wrapped tornadoes, the funnel is completely hidden behind dense walls of precipitation, making it almost impossible to see until it is dangerously close. Hunters must rely on radar signatures and storm structure to estimate the tornado's position, but even then, they sometimes find themselves too close. Road networks create additional hazards. A chaser may need to relocate quickly, but poorly maintained rural roads, flooded crossings, or dead ends can delay escape. A sudden shift in the tornado's direction can trap hunters with little room to maneuver. Even experienced teams have been caught off guard by unexpected turns in a tornado's path. Yet for the scientific community, each dangerous chase brings valuable data. Every measurement, video capture, and atmospheric reading contributes to a deeper understanding of tornado behavior. Hunters accept these dangers because they know their work helps meteorologists save lives, especially in regions where tornadoes strike frequently and with devastating force. Why scientists risk everything for tornado data. The critical reason tornado hunters willingly face such immense danger is because the data they collect is irreplaceable. Traditional radar systems, even advanced Doppler radar, cannot easily capture the fine-scale details within a tornado's inner core. Only close-range instruments and direct interception can reveal the tornado's true structure, but prediction accuracy still needs improvement. Many tornado warnings today cover broad areas, often for storms that never produce a tornado. This leads to warning fatigue, where communities begin to ignore alerts. Narrowing down tornado formation probabilities would revolutionize emergency preparedness, enabling meteorologists to issue precise, reliable warnings that people take seriously. Chasers also gather data on how tornadoes evolve. Some tornadoes begin weak, strengthen rapidly, and then dissipate within minutes. Others maintain structure for hours, carving long paths of destruction. Understanding these differences can help scientists determine which storms are most likely to pose major risks. Ultimately, tornado research is a mission driven by compassion. Scientists know that every data point they collect could one day prevent tragedy. Every dangerous chase becomes part of a larger effort to protect communities and reduce loss of life. The risks they take today may save lives tomorrow, and that makes their work not just important, but essential. The legacy of tornado hunters and the future of storm science. The legacy of tornado hunters is etched into the history of meteorology. Their daring missions, groundbreaking discoveries, and unwavering commitment have fundamentally reshaped our understanding of severe weather. They transformed storm chasing from a fringe pursuit into a respected scientific discipline. Their work created better radar systems, more accurate forecasting models, and improved safety protocols for communities across Tornado Alley and beyond. Future storm science is advancing rapidly. New technologies such as drone surveillance, mobile phased array radar, machine learning prediction models, and satellite-based wind detection promise to revolutionize tornado research. Drones may soon be able to fly directly into tornado funnels where humans cannot go. AI models may one day predict tornado formation with minutes or even hours of additional warning time. Radar networks are becoming more sensitive, allowing scientists to detect subtle atmospheric changes that were invisible a generation ago. Yet, despite technological advances, nothing will replace the irreplaceable instinct of tornado hunters. Their ability to read storms visually, anticipate shifts, position themselves with precision, and respond quickly remains unmatched. Technology assists them, but human judgment remains the ultimate tool. And in just 8 intense minutes, the average time it takes for a tornado to form, mature, and unleash its full force, everything they've risked becomes worth it. Their work transforms chaos into knowledge, and knowledge into safety.